By now, you've probably seen enough about the NB3000 to know it's got some really cool peripherals and development features, but one thing that's particularly useful is the option to boot your design from high-density flash. If you have the Xilinx edition, this can be the Spartan 3AN's internal flash, or if you have the Altera edition, you can use the SPI flash external to the FPGA. In both cases, you can combine your FPGA hardware boot image with your compiled embedded code, making it a portable single flash solution. Here's how. First, let's look at the Xilinx edition. Here's a design that uses the SPI bootloader IP core for copying the embedded code from the SPI flash into the SRAM at boot up. The SPI flash memory used here is actually contained within the FPGA. This part can be found in the Xilinx Spartan 3AN FPGA integrated library, and it's wired up to the bootloader through this predefined harness connector. The bootloader is configured within the OpenBus document to start loading code from the flash address 119800 hex. This is the address of the first user memory page after the FPGA configuration image, and that information is obtained from the Spartan 3AN flash user guide. The bytes to copy field is set based on the size of the ROM section used for our embedded object code, shown here in the embedded project options as 292K. If we wanted to add the SPI memory to the processor as a peripheral, we could do that by checking this box. This box enables us to choose which SPI flash device to address on the Nanoboard SPI system, but since this design is only connecting to the internal flash, we'll not worry about it. The next step is to combine the FPGA bit file and the embedded code into a binary to be stored in the internal flash. In the NB3000XN slideshow example folder, open the provided flash utility executable program and enter the full path and file name for the FPGA bit file as well as the embedded code hex file. Specify an output file name and hit Generate Bin File. Close the flash utility and in Devices view, right-click on the FPGA icon and select Configure Hard Device Flash. Make sure the flash is blank first, and then download the binary file. Hit OK, and then right-click on the NB3000 icon, open the instrument, and choose Settings. Make sure that the option to boot from internal flash is selected. This example also happens to be the golden boot image from the factory. Now, let's look at the same process except with the NB3000AN, or Altera Cyclone 3 version. The Cyclone 3 is a simpler process because it only uses the external SPI flash devices for boot up. There is also an Altera version of the same project in the same example folder. Everything about this project is identical except that it connects to the NB3000 SPI bus and is configured for the Altera Cyclone 3. Use the same flash utility along with the Altera RBF bit file and the same embedded hex output file as before. Create a new binary file. We'll rename this one to make sure we don't overwrite the Xilinx one created before. Now, with the NB3000AL connected and Devices view open, I'll use the Nanoboard instrument panel to program the FPGA boot flash with the binary file. Once that's completed, a quick power cycle gets the design running. For more information about the SPI bus peripherals and flash boot options, visit the Altium Wiki and search for the article SPI Communications on the Nanoboard 3000.